Hello, guys. Excuse me. Hello, scholars. How are you doing today?
Hello.
Hi,
Good,
sir.
you?
Good.
I'm doing okay. Thank you for asking. Um, I want to make sure that you are seeing the screen. Can you see what I have on the screen for now?
Yeah.
Good. So that is our topic for today, the binomial distribution. Remember, I introduced probability distributions on Tuesday, and then, excuse me, then this is one of the probability distributions, but this one is the one we call discrete probability distributions. It is called binomial distributions. There are other ones like the Poisson distribution and so on and so forth, but we will focus on binomial distribution. Now, let's start with binomial experiment. Um, many probability distribution problems in probability um, requires or have two outcomes that's or outcome that can be reduced to two. They have only two outcomes, or they have outcomes that can be reduced to two. That's where the by come from, by two double. So now that is that leads us to the binomial experiment. For example, when a coin is tossed, when you toss a coin, two outcomes, head or tail. That's how it will land. Head or tail. Now, in a basketball game, they might say this team scored so and so point. The other team scored so and so point. Bottom line is this: either one team win or they lose. Two outcomes. Okay. Now we have another example. When a baby is born, it will either be a male or a female. Now, when I say this in the other class, you were asking me how about there are some people that have some birth defects. They were born and they have both the male and female genitals. And I told them in biology, according to biology, even if they have the same male and female genital in them, only one of them will be functional. Only one. And that is the male one is functional and the female one doesn't work. Or the female one is functional and the male doesn't work. It got to be one. Either you're a male or you're a female. So blood pressure, no matter what it rates, either it is normal or it is abnormal. Again, two outcomes. So this will give you these four scenarios will give you an idea of what we are talking here when we say binomial experiment. All these four scenarios described above are examples of binomial experiment. You can explore other examples. So a feature of the binomial experiment is, it is a probability experiment that satisfies the following requirement. That's the requirement of the binomial experiment. A requirement that that probability that situation will have to qualify it as a binomial experiment. One, each trial can have only two outcomes. I think I have already given you examples. So you must have two outcomes, which can be reduced to, or outcome that can be reduced to two. And secondly, is that there must be a fixed number of trials. Now, the outcome of each trial must be independent of each other, and that the probability of success must remain the same for each trial. So you must have two outcomes, success or failure. Now, when we say success, it's not only in the positive side. It depends on what you're looking for. Let's say that let's take having a baby, for example. If what you are looking for is a female child, success becomes if it's a female child. Failure becomes if it's a male child. If you are looking for a male child, then success becomes if. So now that's when we say success in binomial distribution. That's what we mean. Now, so for a dice, you know that the dice have 6 sides. In that case, the probability of success is 1/6. So for any outcome, like when you toss the die and what is the probability that a 4 shows up, is 1/6 chances. It's still constant. That's what it's mean here, that the probability of the success must remain the same for each trial. The same for coin is 1/2. So having given you this background, I think we are now empowered to understand, academically, to understand what a binomial distribution is. A binomial distribution is, a kind of discrete probability distribution. So the outcome of a binomial experiment and the corresponding probability of these outcomes is what we call the binomial distribution. Before you can solve questions that involve binomial distribution, you need to understand some of these notations here. P is the probability of success. Q is the probability of failure, which is always given by this formula. Q is 1 minus P. And X is number of success in N trials. Okay? N is number of trials. So there are 3 ways you can solve this kind of probability. Either you use the formula, which is this one on the screen, or you can use a table, the one I told you to print last on Tuesday. We'll start using it next week for normal distribution. Or you can use this formula, PS equals N combination X times P to the power X times Q to the power N minus X. You guys should remember this part from the video that I told you to watch about counting rules, NCR. So you can get it with a calculator, or you can get it using formula. For this, we will use the calculator to get this part, NCN combination X. Okay? For X, 0, 1, 2 to N. Another way you can do it, you can use Excel to do it. So, let's do an example. Let's look at this example here. Let me copy this formula. You can try this. This one is easy. You can try this one when you get the chance. Let me take the one that let me take this, copy this formula. Okay. Look at this example. It says, it is claimed that a particular flu shot is effective in 70% of the cases. If a group of 15 adults receive the flu shot, find the probability that exactly 10 will benefit from the flu shot. Okay. The first thing you do is to list out these values for N, P, and Q, and X. Then plug them into this formula, you get your answer. Very simple. Now, let's try this one. It says, if it is claimed, okay, good, okay, make sure. It's claimed that a particular flu shot is effective 70% of the time. 70% is the probability of, because it is effective 70%. 70% means that P is 70%, which is 0.7. So if a group of 15 adults, how many adults? 15 adults. So our N is 15. Okay. And you say Q will be 1 minus P, 1 minus 0.70. Okay, which will give us from the calculator 1 minus 0.7. I know it's 0.3, but let me just 0.7 is 0.3. You go ahead and put 0.3. 0.3. 0. Okay. So now, see, we have all of them. We have N as 15, P as 0.7, Q as 0.3. Then the question was, maybe I should make it a little bit bigger. Make it 18. So the question is, find the probability that exactly 10 will benefit from the shot. Okay? That means that X is 10. Then let us plug it into the formula so that P probability of 10, because anywhere you see X, you put 10. Anywhere you see Q, you put 0.3. Anywhere you see P, you put 0.7. Anywhere you see N, anywhere you see them in the formula, put 15. So equals N combination X. So you got 15 combination X is 10 times, I gotta correct this. Okay. I'm gonna make a correction on that. Then 15, I'm gonna correct that too. Okay. Times P to the power X. And our P is 0.7. 0.70 to the power X, which is our X is 10 times, I'm gonna correct that one too. Raised to the power 10 times Q raised to the power N minus X. And our Q is 0.3. 0 raised to the power N minus X. Our N is 15 minus X. And our X is 10. I'm gonna update that, correct that again. Okay. That's all it takes. You can see it. If you don't see it very clear, let me make it bolder. Make it 20. Make it 20. Or 22. Probably make it bold. See? So once you put this in the calculator, you get the answer right away. You get the probability that exactly 10 will benefit from the shot, from the flu shot. Let me write this down so we can get it from the calculator. We got 15 combination 10 times, excuse me, P to the power, P, which is 0.7 raised to the power 10 times 0.3 raised to the power 15 minus 10. And that will give you the answer right away. Let's go and put it on the calculator. So while we do that, I want you to take note of this part here, 15 combination 10. Like I said, that video I told you to watch that you did as a practice homework on counting rules. Part of it is combination. So I will show you how to get this part. You'll see it, and then this one you know already for your algebra class. You can raise, you know how to raise a number to a power. So let's go and put it on the calculator. Now, 15 combination 10, to get that, you go to function, right? You can see the NCR right here. That's the combination right there. Click on it. 15, hammer, 10, close it. Give you the answer, 3003. Then times 0.7 raised to the power 10, okay, then times 0.3 raised to the power. Now you can see that it says raised to the power 15 minus 10, which is 5. So you can just go there and put 5 there. 15 minus 10 is 5. 0.206 rounded. 0.206 rounded. Like 0.206 rounded. I'll go ahead and put it. 0.206. I can say that there is 20.6% chance that that exactly 10 people will benefit from the shot, from the flu shot. Any question on this? Any question, guys? Okay. So I wanted to use this to show you how to use this formula. We are going to do this one too. It's the same process. We're going to do it with Excel just to save, but this is the same process. Do part A using the formula, do part B using the formula, do part C using the formula. So if you use the formula to do all of them, for us, it's going to take us a long time. So we will do it on Excel. I'll show you how to do it. But at least you get the point here. Any question, please let me know if you have any question, guys. Okay, excellent. Excellent. Now that you know how to do it with the formula, let us do this one with let me show you how to do it with Excel, and then we will now make a flashback and solve this one with Excel, and so on and so forth. So now we go to get this on Excel. All you need is the NPQ and X. Let's go and put it right there. Okay. We have let me write the NPQ out. I get our N is 15, our P is 0.7, our Q is 0.3, and our X is 10. Let's go and put it right there. So in Excel, this is blocking it. I'm gonna make it to be, yep, so you can see it. Have our N, P, Q, X. So our N is 15. Okay. Our P is 0.7. Our Q is 0.3. And our X is 10. So for Excel, all you need is, you have all this here. The Excel formula, let me put it in a way that you can see it here. Put equal sign, binom dot dist. That's the formula you're gonna use. Binom dot, oops, excuse me. Binom dot dist, make it 16. 16 should be good enough. Make it bold. That's the formula you need right there. So let's put it right here. So that the probability they ask us to find is the probability that's exactly 10. Okay? Benefits. So the probability of exactly 10 become P of 10 equals, put the equal sign, then type binom dot dist. It will pop out here. Double click. Numbers. X is S is just 10 is the X. That's the probability you're looking for. 10, hammer. How many trials? See the trials right here, which is 15. comma, probability, of course, is 0.7p, okay, comma, then cumulative, use get a type because you're looking for exactly 10. So you're not looking for a cumulative answer. So if you ask you true or false, you're going to put false because false is the probability mass function. So you put false, close it, press the enter key. See, it gives you the same answer we got. Yeah, same answer we got. In if I check it, you change it to three decimal places by clicking on this decrease decimal place. Say 0.206, which is this exactly the same thing we got here. Okay, 0.206. Now, any question in what I did on Excel, guys? You have to ask if you are confused. Can you hear me, guys? Hello?
Yes, no questions.
No question. Good. Excellent. Excellent. Now let's do another one. Like the one I just told you that you choose it, make your choice, choose use formula or you can use it. But if my question say use Excel, then you have to use Excel. Look at this question here. It says find the probability that in 5 tosses of a fair dice, a 3 appears, A at no time, B once, C twice, D 3 times, E 4 times, which means that you're going to use this formula to find the probability that it appears at no time. At no time means 0. Then you use this formula again to calculate the probability that it appears once, which is 1. So that will take you a long time to do all these calculations. So that's why I put that for Excel. But first of all, let us identify our MPQ. So for this one, X is X appears at 0 time. For this one, it means that X it appears 1 time. For this one, X means it appears twice. For this one, X appears 3 times. And for this one, X means it appears 4 times. So we have all what the X values are from 0. Then N, it said find the probability that in 5 tosses, so it was tossed 5 times, so our N is 5. At a dice, at a 3 appears A, at no time B, once C, twice. So we have all the X's. Now P, for a coin, oh, this is a dice, not a coin. The outcome for any of the outcome probability is 1 out of 6, which is okay. 1/6 would be from the calculator we have it at 1/6, 1 divided by 6. It is 0.1666. That means 0.167, 0.167, 0.167, and Q is 1 minus that, 1 minus P, which is small p, which is 1 minus 0.167 equals okay, 1 minus 0.167 is 0.833. 0.833. Okay, now let us write these things down and then we can go in Excel and do it. If something might take us up to 30 minutes, Excel can just do it in a matter of a few minutes, 5 minutes or less. So N is 5, P is 0.167, Q is 0.833. So we have x1, s, x goes from 0 at no time once, twice, so 0, 1, 2, 3, 4. So now let's go and put it in Excel. So Excel. So we have, in this case, let me just to save, I'm just copy this. N is P is Q is, then I'll come here and put our N values. X values, I mean to say X. Let me put it right here. X. So we have 0, 1, 2, sorry, 2, 3, 4. Take 4 of them, I think. So that means we're looking for the PX, P1. Okay. Oh, P0 or 0 equal P1 equal. Oh, you put all when I put you put the rest of them. Okay, good. That's good thing about Excel. Well, the best thing is to remove this. Just put PX here. Put PX right here. PX for each of them. So this is a X0, S1, 2, Now let's do it now. N is 5. P is 0.167 and the Q is 0.833. So we're ready to apply the formula. So remember, equals binom.dist. So we got equals binom.dist, pops out, double click. For numbers, f x, click on this, comma. How many trials? 5 trials, type 5, comma. Probability, P is this right here, of success, comma. Cumulative, no, it's false. We don't want cumulative, so type false right there. Close it, press the enter key. Give you the first one, so that the probability that appear as no time is this one. Then double click on it, you calculate the rest of them. Okay, let's see why it doesn't do this. Okay, let me see what I did wrong. Give me 1 minute, let me correct this. Binom, binom, dot this. Oh, excuse me. I click on something that's again. Numbers, click on this. Comma. Yes, click on it. That's what I didn't do. Number of trials is 5, type 5. Probability is 0.167, comma, then false. See? Then press enter key. Then, say calculate all of them. See, when I click on it, you can see what you did here. So that's how you do it. And see how easy it takes, quick it took us to finish it. So in that similar vein, you can do this one, this type, like here, when it says, I'm gonna put this thing down here. A survey found that 45% of teenager consumers receive their spending money from part-time jobs. Yeah. Part-time jobs. If 6 teenagers are selected at random. Find the probability that at least 3 of them will have part-time jobs. We're gonna use Excel to save us time. To say find the use Excel. Now, these are 6 teenagers. So N is 6. P say so we found that 45% of them. So P is 45%, which is 0.45. Well, if you're using Excel, you don't really need the Q. So, but this time around, it says if 3, oh, give me 1 minute. I want to check something. Okay. All right. It said find the probability that, let me make it a little bit bigger. Make it 18. So find the probability that at least 3 of them. Say, let me highlight it. At least 3 of them. That is a keyword there. Now, at least 3 means, remember binomial goes from 0 to 0, 1, 2 to n last year. At least 3 means, out of these 6, at least 3 means 3 or more. That means you're looking for S is 3, 4, 5, and 6. Which means that if you're using the formula, you're going to use the formula to calculate the probability of 3, then calculate the probability of 4, then calculate it using the formula separate. Calculate the probability of 5, then do that for 6, then add all of them. That can take you up to 30 minutes to 40 minutes, assuming you didn't make any mistake. So because of that, I'm going to use Excel so that the probability of at least 3 of them means equals P of 3 plus probability of 4 plus probability of 5 plus probability of 6. See? Now we can now get this outcome from the Excel. So normally I get all of them, then choose at least 3 from there. So let me write this, what we have down. We got N is 6, P is 0.45, and X. So for X, I'm gonna remember when I defined when I showed you the binomial formula, I said that for X 0, 1 to N, where N is the last number, like here, N is 6. So having that in my mind, it is asking at least 3. I'm gonna release from 0 to 6, then choose at least 3. So let's go and put it right there in Excel. So I have N equals P equals, we don't need Q. So N is 6. P is 0.45. Okay. So you have your N here. Sorry, X. Sorry, let me just put it here. X. So I'm going to go from 0, 1, 2, 3, 4, 5, 6. Then probability of X here, Px. So that we have equals binom.dist. Double click. Number, that's X is right here. Click on it, comma. How many trials? 6 trials. You can see N is 6. Comma. Probabilities is a P 0.45. Comma. Cumulative no, top to type false. close the parenthesis, press the enter key. See, and then you double click or you can drag it down. Now, but what we are looking for is at least 3, I believe. Let's see on the question. Yep, at least find the probability of that at least 3 of them, which means probability of 3 plus probability of 4 plus P of 5 plus P of 6. So we can get it from there. So that we have the probability of at least 3 equal okay, 3 equals, I'll make sure you're seeing this. Yep, you're seeing it. Equals, start from 3, you add this plus this plus this and plus that. Say 0.558. Write it down. 0.558. So we can go to your workbook and add it. 0.558. Or there is 55.8% chance that at least 3 of them will have part-time jobs. Yeah. Any question on this? Yeah. No question. Excellent. Now, I think I have given you enough for you to be practicing on this. Let us go to the rounding up. Yeah, so this roundup, so in this section, we'll be looking at how to compute the mean, variance, and standard deviation of a probability of a binomial distribution. The mean is simply got by multiplying n times p. That's the formula. Variance is n times p times q, and the standard deviation is the square root of variance. Let's do one example on this one. Okay. Here it says, find the mean, variance, and standard deviation for each of these. Let's try this number part A. Here, n equals 100. N equals 100. P equals 0.75. They didn't give you the Q, so you have to get it by yourself. Q equals 1 minus P, which is 1 minus 0.75. And that gives you I think it's 0.25, but let me just confirm. 1 minus 0.75. That's 0.25. Yes, I was correct. 0.25. At least I still remember something. 0.25. So the mean equals n times p, which is 100 times 0.75. That gives you 75. Variance equals n times p times q, which is 100 times 0.75 times 0.25. So you can get it from the calculator. Okay. Got 100 times 0.75 times 0.25. 18.75. 18.75. You got 18.75. Okay. Standard deviation, you're going to find the square root of variance. Now, because this workbook will not allow us to put the square root symbol, so I'm going to take it to the next workbook and then copy it and paste it here. 18.75. So let's go and get it from that workbook and then come back and put it right here. So that the standard deviation, okay, standard deviation equal square root of 18.75 equals, let's find it on the calculator, 18.75 square root of 18.75, 4.33, 4.33. Look at it again. 18 points, yeah, 18 points, yeah, 4.33. 4.33. So I'm going to copy this and paste it here. Okay. So pasting it right here. Any question on this, guys? Any question? No questions. Okay, then let us round up. Look at the application here. It says the statistical bulletin published by the Metropolitan Insurance Company reported that 2% of all American bets result to twins. The random sample of 8,000 bets is taken. Find the mean, variance, and standard deviation of the number of bets that will result to twins. So the answer is, how many of them we are select? How many sample? 8,000 bets. So our N equals 8,000 bets. P said the company reported that 2% of all American bets are twins. So P is percent. 2%, which is 0.02. And Q equals 1 minus P, which is 1 minus 0.02. I think it's 98%, but let me double check. That's 0.98. Let me just double check. Okay. 1 minus 0.98. Yes. 1 minus 0.02. 0.98. 0.98. So it's 0.98. So that's the average as a mean becomes N times P, which is 8,000 times 0.02. So 8,000 times 0.02, 8,000 times 0.02, 160. So on average, 160 bets, 160 American bets result to twins. That's what it says. Then for the variance, we have N times P times Q, which is 8,000 times 0.02 times Q, which is 0.98. So we got 8,000 times 0.02 times 0.98. 156.8. 156.8. Okay. 156.8. And standard deviation, I'm gonna remember this workbook will not allow us to put the standard deviation formula here. So let me go and get it from that workbook. So we'll take you to that workbook. Got square root of 156.8. So we're gonna get it from the calculator. 156.8. Square root of 156.8. 12.52. 12.52. Okay. Come put it here and then take it to the 12.52. I'm gonna copy this to C and paste it in your memo book. Yeah, Viola, we finished. So any question before we round up? Any question, guys? Hello, scholars, can you hear me? Any question? You still there?
No questions.
Huh?
No questions.
All right, guys, so I'll see you on Tuesday then. You have a nice day, a nice weekend.
You as well. Thank you.
You're welcome.